In the name of Allah, the most gracious, the most merciful. Praise be to Allah, and peace and blessings be upon the Messenger of Allah, our Master Muhammad, and upon his family and companions altogether. Now let's continue with a new lecture on current and voltage transformers. There are two types of transformers, the magnetic or inductive type and the V type for up to 145 kV. The CVT is used above 145 kV. It is not called a VT and is used with a 145 kV cable. As for the other transformer, what is the CVT transformer as a voltage transformer and is used with a 145 kV cable? In high voltage situations, using a VT is costly. CVT steps down high voltages cost effectively. A drawback of CVT is more waveform distortion than VT due to capacitors. Modern digital relays can restore original waveform. Capacitors in series. Drop voltage for VT conversion. Low impedance requires high capacitance. A drawback is greater waveform distortion than a VT. Digital relays restore waveforms. Series capacitors drop voltage for VT conversion, needing low impedance and high capacitance, making C2 larger than C1. In a double bus diagram, a VT connects via a disconnector. VT has two windings, one for protection and measurement, another for protection. In this image, we can see capacitors connected in series, and the purpose of connecting the capacitors in series is to create a voltage drop across them. We need to create a voltage drop to reach a lower voltage that we want to convert through the VT. Since we need a lower voltage, this means we need low impedance, and low impedance requires high capacitance values. Therefore, the value of C2 will be much larger than the value of C1. In this diagram, a VT connects to the balance. It has two windings, one for protection and measurement. 16A MCB protects the VT from load, short circuit, or transient voltages. After the MCB, voltages distribute with winding 1 going to 6 locations. The first MCB links to the PCU for measurement, comparing line and busbar voltages. Here we place a 16A MCB to protect this VT from any sudden load or short circuit in the windings, or any transient voltages that may occur on the side of the VT. After this MCB, the voltages are distributed to their appropriate places with winding 1, which is above, distributing to 6 locations, but 2 of them are spares for future use. Notice that the rated MCB here is only 2A. So the rated value of the main MCB is always higher than that of the sub MCB. We notice that the first MCB goes to the PCU for two purposes. The first is for measurement, and the second is to allow the circuit breaker to close through the synchro check. Principle of its operation is to compare voltage checks, so the synchro check needs a voltage check, and to compare them to allow the circuit breaker to close, which involves checking the line voltage and the busbar voltage. The line voltage and the busbar voltage. Notice here the line voltage and here the busbar voltage. It's very dangerous to close the circuit breaker on different voltages, and that's the essence of voltage itself. So when we say that the voltage is red to yellow or phase-to-phase voltage, it means there's a connection between two different voltages, the red voltage and the yellow voltage. The synchro check compares the magnitude values, phase angle, and frequency, which should somewhat match. The second path goes to 98. The 98 here is the under voltage relay, or we can call it the VT fuse failure, which is used to create an interlock to prevent the closing of the earth switch. There is a fuse failure. The PCU might think that there is no voltage on the line. The earth switch is closed, and it closes on a very dangerous voltage, which is a type of fault called phase-to-earth fault. This signal is used to prevent the closing of the earth switch at the remote line end in the other distant station. This signal is sent to the protection relay and transmitted to the second station via fiber optic to prevent the earth switch from operating there. To avoid any incorrect operation of the earth switch when there is voltage on the fourth path going to the DSM, which is the dynamic system monitor, it continuously monitors the voltage and stores it for reference in case of faults to understand the behavior of the voltage for a period before the fault occurs. The third path is used for distance and directional earth fault protection as the main protection 1. The first path from winding 2 is used for distance and directional earth fault in the second main protection. Here we notice that the first main protection takes the voltage from winding 1, while the second main protection takes the voltage from winding 2. The great revival of a nation